Algebra 2, Chapter 2, Section 4, Algebraic Fractions. Algebraic fractions are fractions involving algebraic expressions. And algebraic fractions can be simplified by canceling any common non-zero expressions that are in both the numerator and the denominator. Furthermore, algebraic fractions can be split, combined, etc. in the same way as normal fractions. So as a reminder of our rules of fractions, we can add two fractions with different denominators by multiplying the first fraction by the denominator of the second and the second fraction by the denominator of the first, and then adding the numerators. Similar with subtraction, for multiplication we simply multiply numerators and multiply denominators. For division, we turn the division into a multiplication by flipping or reciprocating the reciprocating the denominator. So the denominator, instead of being c over d, becomes d over c. Multiply and then combine just as in multiplication. So let's practice using these rules. Let's simplify the following fraction, 6x minus 6 divided by 3. So to do this, we need to find common factors between the numerator and the denominator. If we pull out a 3 from the numerator, we have a 3 in the numerator, a 3 in the denominator. 3 divided by 3 is just 1. That leaves us with 2x minus 2. Much simpler. In fact, we could even go a step further and write this as 2 times x minus 1. Maybe we'll make that our final answer. Simplify this fraction. So let's find common things. Looks like there's a 5 in common everywhere. So we pull a 5 out of the numerator, a 5 out of the denominator, minus 3m minus n. 5's cancel. We're left with 2m plus 4n over minus 3m minus n. And it might be nicer to write the minus sign out in front of the fraction and to take any more common factors away from just the numerator or denominator. So in the denominator we have a common negative 1, and we often write that negative 1 in front of the fraction bar. So we just have 3m plus n in the denominator. This minus looks funny. Let's clean it up a little bit. Minus. And then in the numerator we might have, or we would factor out the 2 and be left with 2 times the product, 2 times the quantity m plus 2n, all divided by 3m plus n. Of course, we negate the answer of that previous calculation. What about simplifying this fraction? Again, pull out common things. Here we have a 5a in common, so we have a squared plus 2. And then denominator, we have a common 10. 10 times a squared plus 2. There's a 5 in common. 10 is 5 times 2. And the a squared plus 2 is in common. And no, a squared plus 2 can never be 0. We don't even have to think about division by 0 here. So we're just left with a divided by 2, which is a much simpler form of the fraction. Simplified this fraction. So let's take out the 2 from the numerator, k squared minus 4, and 2 minus k is in the denominator. Now here we remember, it's perfect squares being subtracted. We can factor this into k minus 2, k plus 2 is the difference of squares for 2 minus k. And then remembering back to chapter 1, we can negate a subtraction by multiplying by negative 1 or factoring a negative 1 out. If we do that, we're left with 2k minus 2, k plus 2 over negative k minus 2. Or we could even write the negative sign in front of the fraction. Now, provided that k does not equal 2, assuming that, which we kind of assume here at the beginning of this problem, then we can cancel the k minus 2 out. And we have minus 2k plus 2. as our final answer. Now, what about adding? Let's practice adding some fractions here. So remember, we need to multiply first fraction by the denominator of the second. So 30c over 25 times 30, which we'll need a calculator to help us with. 30 times 25 is 750. So we'll have 30c over 750 plus 25h over 750, which equals 30c plus 25h over 750. But we still have some common factors in the numerator. Factoring out of 5, 6c plus 5h over 750. And 5 goes into 750. So divide 750 by 5, 150. So that would lead us with 150 in the numerator. So our final answer would be 150 in the denominator. 6c plus 5h over 150. Let's do a word problem. Suppose a car's fuel efficiency is 25 miles per gallon in the city. So the city, we get 25 miles a gallon. And 30 in the highway. So we get better miles to the gallon on the highway. Find the average fuel efficiency in miles per gallon if the car drives 150 miles in the city and 300 miles on the highway. So to do this, we know the miles in our miles per gallon. We need to find the amount of gallons that were consumed. So if we take 150 miles and multiply by the fuel efficiency, we'd have miles times miles. That's not what we want. So we need to divide. So we have 150 miles. We need to divide by the fuel efficiency or reciprocate this fraction to be gallons per mile instead of miles per gallon. So if we reciprocate the fraction, we get in 1 gallon, we go 25 miles. And then we'll find gallons for city. Although I used the wrong, city, yeah, 25. Okay, that's the miles for the city. If we add the miles for the highway, we'll get the total miles. So 300 miles times 30 miles in 1 gallon. So this unit analysis is very useful because we can treat the units kind of like variables, cancel them to see that we get the correct units back out. So here we're going to have gallons plus gallons, which is gallons of fuel. Okay, so we just need to do the math. 150 over 25 plus 300 over 30 so let's find a calculator. 150 divided by 25 plus 300 over 30, 16. So that gives us 16 gallons. We use 16 gallons of fuel. Okay, now we need to take the gallons, take the number of miles, 150 miles. Sorry, not 150, the total miles, 450 miles total we traveled, divided by the 16 gallons to get the final miles per gallon, or the average miles per gallon. It asked for the average fuel efficiency. Efficiency, looks like there's this typo there, sorry. So that division gives us 28.125 miles per gallon. 125 miles per gallon. Okay, that's the answer to the first part of the question. The second part of the question asks us to find the fuel efficiency if the car drives C miles in the city and H in the highway. So here we're replacing our concrete numbers with abstract numbers and coming up with an expression. So the average fuel efficiency was, so that the average fuel efficiency, I'm just going to write average MPG, was equal to the city miles, which was, we're going to call C, plus the highway miles, remember that was this 450, divided by all the gallons. To get the gallons, we have to take the city miles divided by the 25, and then we have the highway miles divided by the 30. So now we need to simplify this algebraic fraction. Okay, so the c plus h in the numerator stays. In the denominator, we need to simplify this fraction by combining these into one fraction. So we need to multiply 30 by c and 25 by h. And if we just happen to think back, this is c over 25 plus h over 30. We just did this part of the problem earlier. So if we copy our answer from up here, 6c plus 5h over 150, 6c plus 5h over 150 is the numerator by the problem we did previously. Now we need to remember the rule where we multiply by the reciprocal to combine these parts of the fraction. So coming over here, this equals c plus h times this new denominator reciprocated, 150 over 6c plus 5h. And combining the numerators, so we get 150, or multiply them together, times c plus h over 6c plus 5h. And that's the answer to the second part, so we'll square that here. So we could plug any numbers now into that expression and get any average fuel efficiency given certain city and highway miles. Now let's simplify this complex fraction here. Well, it's not complex. This is the multiplication of these two fractions here. First, let's go ahead and factor the various quadratics. So we have this quadratic in the numerator, z squared plus z minus 6. So 1 times minus 6 is minus 6. What two things multiply to minus 6 but add to 1? Well, that would be minus 2 and 3. When I take minus 2 and add 3, I get 1, and I multiply, I get minus 6. So that this will be z minus 2, since the coefficient of z squared is 1, I don't have to do the factor by grouping part. Z minus 2 times z plus 3. Now subtracting two perfect squares, I can use the difference of squares, z minus 1, z plus 1. And now remember, multiplying fractions, we can just multiply the numerators and the denominators. Now let's find over here to the side, we should think about which parts of the denominator might be 0 and write that down. Z should not be minus 1, it should not be 1, and it should not be 2, because if it's any of those values, we get a 0. So let's write that over here to the side. Now, now that we've done this, we can cancel the terms that are the same. Z minus 2, z minus 2, z minus 1, z minus 1, and that leaves us with z plus 3 over z plus 1. Much simpler fraction than what we started with. And for a final example, let's simplify this complex fraction. So a complex fraction is a fraction of fractions. So here we have a division. Let's start by applying the multiply by the reciprocal. So we have r squared minus 25 over 5r times, not r squared there, the reciprocal, 5r minus 25 divided by r squared minus 10r plus 25. So now we can regroup essentially, or multiply the numerators, and we can also factor at the same time. We have r squared minus 25, that's the difference of squares, r minus 5, r plus 5. Here we have a 5, we could factor out. I'm left with r minus 5 divided by a 5r in the numerator, and then this thing we need to factor. So here we have 1 times 25, 25. We need to find factors of 25 that add to negative 10. That'll be negative 5, negative 5. Oh, this is a perfect square. So as we have negative 5, negative 5. So it'll just be r minus 5 squared. Okay, so r minus 5 squared. We have the 5 here, cancels with the 5 here. We have 2r minus 5s in the numerator, and we actually have 2 in the denominator if we write this perfect square the long way. And we can cancel these. And we should write over here, r should not be 5. And also r should not be 0, because we have this r in the numerator. And we're left with r plus 5 divided by r. Much simpler than that.